Good day, Philu. Setso is back. Today, I just want us to focus on this concept now, which is the sum to infinity. See now, the sum to infinity. Under this concept, we have two branches. Firstly, we have what? The convergent series. See now, we have the convergent series. We also have what? The divergent series over there. You see, we have two of these, the convergent series as well as what? The divergent series. Then now, what I'm going to do is I'm going to firstly explain the convergent series. You see now, I'm going to start with the convergent series. As for the convergent series, you just need to know that this kind, it tends to approach zero. You see now, and this series, it tends to approach as what? Zero. You see, let me just give you a general formula. Let's say if now let's say if we have a general formula of 1 over 2, and let's say if we have the following general formula, then I ask you now to figure out the series for this given general formula. Then one would say, where I see n, I'll start to substitute 1. Then when I use my calculator for this one, it's much simpler. We are going to get 1 over 2, you see, which is our term 1. You see, term 1, which is 1 over 2. Now let us try to figure out the value of term number 2. For term number 2, where we see n, just need to substitute 2. Let us use our calculator. We're going to get 1 over 4. There is no need for us to put some brackets here. Let me just remove 1 over 2, 1. You see, for term number 2, we get 1 over 4. If we were to continue again by substituting term number 3, we would get, sorry about the light, we would get, we would get 1 over 8. You see, we would get 1 over 8, which is term number 3 now, 1 over 8. You see, we already know that the first term will always be the value of a. And now, if we were to determine the value of r, in this case, we'd say now term 2 divided by term 1. You see, term 2, which is 1 over 4, divided by term 1, which is 1 over 2. It's so simple. We are going to get 1 over 2. Same applies if we find the value of r using term 3 and term 2. We would say now term 3 divided by term 2. For that one, we are going to get the same answer, which is 1 over 2. And this constant ratio it must be the same throughout. You see, for the geometric series, you see. Then from this, I just want us to figure out the relationship now between what? between n and what? And Rn. You see? I just want us now to determine the relationship between the two. Check. For this given general formula, what we did is we substituted the value of n from term 1, term 2, term 3. If we were to continue substituting more value towards infinity, what is going to happen to the value of Rn? Let's check. Firstly, we got 1 over 2. Secondly, we got 1 over 4. Thirdly, we got 1 over 8. If we were to continue like that, those values, each and every time they do what, they decrease. In a way, they tend to approach what? 0. You see, the more we increase the value of n, the more this Rn approaches what now? 0. You see? Then yeah, from here, one thing that you must bear in mind is that as for the convergent series, the value of R will always be between -1 and 1. You see, it will always be between -1 and 1. And last time we were busy with this formula. See, the sum for the geometric. Do you still remember this formula? We were busy with this formula. Then now we found out that for sum to infinity, the more n approaches infinity, what is going to happen now to this value of Rn? You see, they decrease. Eventually they approach what? 0. You see, this value is going to be what now? It's going to be 0. This value is going to be 0. Eventually, if we multiply throughout by a, we are going to get, a divided by 1 minus r, which is our formula that we are going to use to calculate what? Sum to infinity. You see, we are going to use this formula to calculate what? The sum of infinity. We are going to need what? A value as well as r value, which is our ratio. You see, if I can even apply this formula, let me quickly explain the divergent. As for the divergent, this one, it grows further. You see, it grows further. Let us consider this general formula Tn to be 2n. See, what I'm going to do now from this, I'm going to do more like the first one by considering the general formula given, where I see n, going to plug 1. Then this is simple. I'm going to get 2, which is my first term. 2. Let us see now term 2, where we see n, we plug in 2 now. It's going to be 4. You see, if I were to continue term 2, if I were to continue by substituting 3, now I'm going to get 8 plus 8. You see, which is my term 3. We also know that the first term is going to be what? A. You see, if we were to determine the value of r, we do the same by saying, sorry, t2 divided by t1. See, t2 divided by t1, going to get 2. Same applies if I take term 3 divided by term 2. Term 3 divided by term 2. 8 divided by 4. Still going to get 2, which is my r in this case. You see? Check now. Let us try to figure out the relationship between the n value as well as Rn value. You see, we want to know now what is going to happen if n approaches infinity to Rn. See, we want to know. Check. We started by substituting 1, 2, 3. The value of n increases. Then now, what is going to happen to the value of Rn for the divergent series? Check. We started with 2, we went to 4, we went to 8. Eventually, we can clearly see that the value of Rn for this one does what? It also approaches what? Infinity. It also grows. You see, it also grows. Do you understand? Then now, for this one, you just need to know that the value of r will be greater than 1, or at some point the value of r is going to be less than -1, which is true. You see 2 is greater than 1. Then now, at this point, sorry about the light over there. At this point, what I'm going to do is I want us to apply this formula. Let me just erase here. You see, I want us to apply this formula, sum to infinity is equal to a1 over r. See, I hope you can see over there. Suppose if, let's say, they give us the following series: 16, 8, 4, then it continues like that for infinity terms. For infinity terms. See? Then now, let's say they ask us to determine, now the sum to infinity. Sum to infinity of this given series. How are you going to do that? We know that this is our term 1, term 2, also term 3. What we are going to do now is we are going to consider those terms and try to figure out what now the value of r. You see, because we already know the value of a, which is 16. It's so simple, isn't it? Then to determine the value of r, we are going to take t2 first divided by t1, which is 8 divided by 16. If you take 8 divided by 16, you must get 1 over 2. Same for this one. Let us take t3 divided by T2. You must get again 1 over 2, which is what? Our R. At this point, we have our A value. We also have our R value. We can then do what? Substitute. See? Can then do what? Substitute. Or before I can even continue, by looking at the value of R, is this a divergent or a convergent series? Clearly it is what? Convergent. Why? Because the value of R is between -1 and 1. And now let us continue. A value is 16. 1 minus R value, it's 1 over 2. See? Then 16 minus 1 minus 1 over 2, still get 1 over 2. If you further simplify this, you must get the value of 32 for this one. I hope you do understand the following. Let us continue. Now, what I'm going to do is, let's say if I decide to give you this question which says now, consider, I hope you can see, yeah. Let's say consider now the series, see, the series 16k plus 8k squared plus 4k to the power 3. It continues like that. It continues like that. And I decide now to ask you this question, is to say now, for which values of k will the series converges. You see, for which values of k will this converges? Don't forget that we said for this series to converge, the value of R, it must be between what? -1 and 1. Then let us consider the given. We are going to take the given. See, let us consider the given for 3. We know that this one is our A value. But now we need to find the values of k. For which values of k will the series now converges? Let us determine the value of R. This is our term 1. We have term 2 somewhere here. We have term 3. We must take this term 2 and divide it by term 1. See, let me do this one somewhere here. Term 2, which is k squared, we have 16k. You see, 8 into 8 goes once, then into 16, 2. How many k's do we have here? We have 2. It's like, if I like to, I would say k multiplied by k. 1k will cancel 1k. I'm going to have 1k divided by 2. See, divided by 2. Let us check if we still get the same thing this side. It's like now I have 4 for this one. I have 4 k to the power 3 divided by 8k squared. You see, 4 into 4 goes 1 into 8 twice. See, or you can just use the law of exponent by taking this one to the numerator. Is going to be k3 minus 2, which is 1k divided by 2. Same, k divided by 2. Now this is our value of r. You see, this is our value of r. We can then now say, oh, where we see r now, we substitute this. Let me say k, there is no need for us to put 1 over 2. Then this side we have 1. Can then do what? Multiply by 2 this side and multiply by 2 this side as well. Somewhere here, you see. Then 2 cancels 2, going to be left with k, this side minus 2, this side I'm going to be left with 2. You see, I hope you do understand the following. Then now we managed to do what? We managed to do the convergent series as well as I also explained the divergent series. Then we did some examples for using this formula. You see, using this formula, we further went into this application whereby now we determine what the values of k for which the series do what now converges. Then I thank you, and if you are new to this channel, kindly don't forget to subscribe and enjoy your day.